Well, in this screencast, we turn the tables and look at the standard subtraction algorithm, the thing that drives some small people absolutely bonkers and their parents. So let's take a look at something that's fairly basic. Let's do 93 minus 72. If you are like many second and third graders, you know how to do this. 3 minus 2, that's 1. 9 minus 7, that's 2. And so the answer is 21. Why? Why does that work? Well, those are ones. Those are tens. If there are 3 ones and we take away 2 of those ones, that leaves 1 1. If there are 9 tens and we take away 7 tens, then there are 2 tens remaining. 2 tens and a 1, that's 21. And so you think to yourself, how hard could this be? And then somebody comes along and asks you to subtract 215 minus 127. And the whole world goes bonkers. Why? Because in the takeaway model, if there are 5 ones, you cannot subtract 7 ones. So what do you do? If there are 5 ones, you can't subtract 7 ones. What do you do? Oh yeah, you borrow. You borrow from here and bring over there. Why? Why does that work? How do you just magically turn a 5 into a 15? Well, let's think about what it is that we borrowed. We took away a 10 from the tens column. We took a 10 away from the tens column. We had these 5 over here, and we tried to take away, oh, no, we tried to take away 7 and we couldn't do it. We were like trying to take away 7 and we couldn't do it. We ended up short. So we took this 10 from the tens column, and now we're going to bring that over into the ones column. But to bring that over into the ones column, we've got to break it up into 10 little pieces. So now this 10 exists as 10 little pieces. Can we take away 7 now? Sure we can. So this little 1 turns the 5 into a 15. It turns this 5 into this 15. That's what's happening. And then we subtract 7 and we end up with 8. So then we go to the tens place. In the tens place, there are no tens. So we cannot take away 2 tens. That doesn't work. So we go into the hundreds place and we borrow 100. Well, that 100 looks like this. And we break that 100 10. We break that 100 into 10 of these sticky things. We break that 100 into 10 tens, because that's what it is. And we bring that over to here so that there are not no tens anymore. There are 10 tens. And we can subtract 2 of those tens. There are 8 tens left over. There's 100 left in the hundreds column. We subtract it out, we take it away, and the answer is 88. So the whole idea of borrowing is really just fancy regrouping. It's recognizing that a 10 is, let's do it with color. It's recognizing that a 10 is really 10. It's recognizing that 100 is really 10 tens. That's what's going on. So when we borrow, we use our knowledge of place value to rewrite things in a creative way. Does this hold in other bases? You betcha. If we're in base 6 and the place values are 1s and 6s, 4 1s take away 3 1s, that's a 1. 2 6s take away 1 6, that's a 6. The answer is 1 1 base 6. No problem. But what happens in base 12? In base 12, when we have 6 1s, these are 1s, these are 12s, these are 144s. When we have 6 1s and we try to take away 10 1s, we can't do that. So we can't take away 10 from 6. So we've got to go to the next place value over and we've got to steal one of their sticks. That stick is a 12. So when we bring this over, we've got 112 and 6 1s. So this is the number that we would call 18. 18 minus 10 is 8. Then the rest of the subtraction goes the way it should. 4 minus 1 is 3. 2 minus 1 is 1. We have one group of 144, 3 sticks of 12, and 8 1s left over. And that's your answer, base 12. If I can talk briefly about 2 other algorithms for subtraction. There's one that's a little bit popular. It's called the equal additions algorithm. Equal additions says this: I don't like to borrow. Borrowing for me is hard, but adding for me is easy. And so I'm going to add a number both here and here so that I don't have to borrow in this place. If I add 2, I won't have to borrow in the ones place. But to do that down here, I've got to do it up there. This question has the same answer that that one does. But then I'll have to borrow in the tens place. I don't want to borrow. So I want to add a number that's going to make sure that I don't have to borrow in the tens place. Then I got to add it up here. This question has the same answer that this question does. And so I can subtract. Super easy. Super easy. We add numbers in such a way that I don't have to borrow. We add numbers in such a way that I don't have to borrow. The other algorithm that sometimes is effective is the counting up algorithm. Let's pretend that we're trying to subtract 100 minus 42. We're going to count up from 42 up to 100. So we think about, how do I get from 42 to some nice number? Well, we can get to a nice number. And then how do I get from that nice number up to 100? Well, that's not too bad. And so then adding those numbers together gives us the answer that we're looking for. Counting up is effective for kids who are good at adding and not so much with subtracting. Hope these are helpful to you and that you understand place values. See you soon.